Assalamualaikum and hi, my name is Amirah binti Muhammad Fazil. My metric number is 285299. I'm from Group C in Introduction to Mathematical Economics and I take course Bachelor of Science Economics in UUM. In this video, I will share three content which are convexity, marginal cost and interpretation, and revenue cost and profit function. The first question A is about determining the concavity of a function. Where is the function of fx concave upward and where it is concave downward? So let's look at the question. Where is the function of fx concave upward and where is the concave downward? Okay, to solve this question, firstly, to find the differentiate using the power rules. Using that rules, we can get first derivative of functions, which is 3x squared minus 12x plus 18. And then, to do second derivative to find the concave is upward or downward, with the same rules, we can get second derivative is equal to 6x minus 12. We move to the step 2. The second derivative of x will equal to 0 because we want to find the interval. So 6x minus 12 equal to 0 and we get the x equal to 2. Okay, for the step 3, to identify where concave upward or downward, by testing the number in interval, to make it more clear and easy to see, you can draw the table for the number that you want to test. So in this example, I choose number 3 and number 1 to test the value of second derivative. Following the third column, you can see the maximum and minimum number of second derivative function, and the next column is a sign either positive or negative. And lastly, the concavity, whether the number obtained is greater than 0, a positive value, or less than 0 is a negative value. So, if the value of second derivative is greater than 0 on that interval, that is upward, and the value of second derivative is less than 0 on that interval means it's downward. To sum out, when the second derivative function of x more than 0 for each value of x on the interval 2 positive infinity, then function is concave upward on the interval 2 positive infinity. Meanwhile, when the second derivative function less than 0 for each value of x on the interval negative infinity 2, then function is concave downward on interval negative infinity 2. Okay, now we move to C and solve for question 1b. Before that, let we see the question. Suppose that the cost function for a manufacturer is given by Cx equal to 0.00001 x cubed minus 0.003 x squared plus 5x plus 1000. Describe the behavior of the marginal cost function. For B1, we have to find the marginal cost function, while question B, describe the behavior of the marginal cost function, whether concave upward or concave downward, and we have to prove it. This question, we want to find the marginal cost and how to interpret it. Question B1 asks to find the marginal cost function. Firstly, we must find the derivative of the function Cx equal to 0.00001 x cubed minus 0.003 x squared plus 1000, and from that we can find first derivative, which is Cx equal to 0.00003 x squared minus 0.006 x plus 5. To get that first derivative, we have to times the power of x with the number in front of the x. So, for the x that does not have any power, will be disappear automatically. And also for the number that does not have the value of x, will disappear too. Okay, next question B2. Describe the behavior of the marginal cost function, whether concave upward or concave downward, and must to prove it. So, for the solution, we have to use the function in the equation, which is Cx equal to 0.00001 x cubed minus 0.003 x squared plus 5x plus 1000 to find the first and second derivative. First derivative is equal to 0.00003 x squared minus 0.006x plus 5, and the second derivative is 0.0006x minus 0.006, and then we set Cx equal to 0 in second derivative function to get the value of x. So we get that x equal to 1000. So as we can set the graph as well, the right side will be positive while left side will be negative. We can choose any number that are above and below than 1000. For example, I choose 1500, which is above than 1000, and I choose 500 below than 1000. After that, we must substitute the 1500 into the function and we will get 0.03, which is more than 0, and substitute that 5 1000 and we will get negative 0.03, which is less than 0. So, since the x is larger than 0, marginal cost function is concave outward. Thus, concave outward is 1000 to infinity and concave downward negative infinity to 1000. Question 1c is related about revenue, cost and profit function. So let we see the question. A company has established that the revenue function in Ringgit Malaysia is equal to 2x cubed plus 40x squared plus 8x. And the cost function in Ringgit Malaysia is equal to 3x cubed plus 19x squared plus 18x minus 800. 1. Find the level of production that will yield a maximum profit for the company, and find the price per unit to maximize the profit. Okay, for the question, to find the level of production that will yield a maximum profit for the company, step 1 is we have to find the profit function. To find profit function, we use the total revenue minus the total cost. And we get the profit function is equal to negative x cubed plus 21x squared minus 72x plus 800. After that, step 2, we can now find the first derivative of profit function using the power rule, which is equal to negative 3x squared plus 42x minus 72, and then let it equal to 0 to determine the level of production will maximize profit. So, when it equal to 0, we get two levels of production, which is 12 and 2. Okay, for the step 3, to know there is a maximum or minimum or an inflection, check using the second order condition known as SOC. Then we insert the value 12 and 2 into the secondary of profit function where we got a negative 30 when the production level is equal to 12, while positive 30 when the production level is 2. So while is equal to 12, the function is negative 30, which is less than 0 and therefore is the maximum. While when the level of production is equal to 2, the number is positive 30, which is greater than 0, therefore is the minimum level. Okay, for the last question, to find the price per unit that maximize profit, we use back the level of production, which is will maximize the profit, which is 12, and we insert into the profit function and divide by 12, and we will get the price per unit that maximize the profit is 102 ringgit 67 cents. So that's all from me. I hope it can share some benefit through this video. Thanks for watching.